Okay, the next question is, as I said, each edge or branch that is represent a revolutionary time. So, based on this revolutionary time, we can estimate, as I said, when we compare to two species, A and B and C and so on, we can estimate the distance between two species. Then, how we can estimate as mathematically between two species? If we find a model, exists model, when there is a deeply related, then the value is small, and otherwise the value will be bigger than the related species. Okay, now how we can estimate between the two species? The answer comes from p-adic distance. Okay, what is distance? This distance between, when you think about a plane, not a plane, a horizontal line, okay, is R is given, and x, y is 2 points is given, then we can estimate between the distance, I pick the x, y, and z, we can estimate distance dxg, g, dgy, and dxy. And this matrix is usually the absolute value between two species, okay? But in this case, such a metric system does not nice model, obviously. Anyway, we can construct a new and reasonable metric space that estimate the following evolutionary model, that p-adic distance is nice model to describe the two species. Okay, but what is the p-adic? In this lecture, I will not explain everything of p-adic metric. That field is a p-adic number theory. So I will explain a part of the p-adic metric, p-adic field. So before to define a p-adic distance, I will start the ordinal number that is based on to define p-adic theory. Okay. Let p be a prime number, and for any integer a is given, consider p to m. Okay. Then if m is the highest power of p, such that an integer a is divided by pm, then we denote it denote search power M by ord PA, and we call this number is an ordinal A base P. So that is ordinal number. So for example, when we compute ordinal 250 base, the prime number 5 is 3. We can find the maximal number m that divided by the maximal number m that divides 250. In that case, if we take 1, 2, that divides the number, but we can find the maximum number 3. If m is 4, then it's impossible because that is greater than 250. Okay, so we can in this way we can find the maximum number m that divides the 250. And in particular, if A this is 0, then we can define zero is infinite. And we can see these guys as a function. When we fix prime number P. This means that is ord P. The domain is an integer. We can allow so the negative number is okay. And that spew out the natural number. That is clearly natural number. And in case of 0, we can allow plus infinity. So that is here. We can define ord PA, the maximum number of integer that satisfies the following modular at P. If A is non-zero and plus infinity A is 0. In that case, we can understand that is a function that plays the role that is similar role and logarithm. So let's see the following proposition. prime number and a, b an integer, then we can satisfy like a logarithm formula. That's here. What is in case of log, that rules are satisfied, and we can consider about the log based at a, that is also satisfies the formula. In this case, the ordinal at p is very similar like a log. And our next idea or desire, okay, we can understand that is a function. We can extend the ordinal function into domain rational number. It is strange because the ordinal function spew out the must be integer, okay? But we can, based on the following proposition, by defining, we dare to define log, and that because it's a rational number, we can find, okay, that is ord p q to here. So when we take the r over s, of course the given condition is given and so on, then we can define, that is define, I said that is similar rule of log like this. Well, that is a also similar logarithm formula like this. Okay, then our question is naturally boils down to that definition is natural or well defined. In fact, the process, the extent, the domain G to Q is the process of that is related to that is reasonable when we consider a discrete, the abstract algebra concept, discrete valuation or discrete valuation ring.